Thanks very much. So, this is 6 months of Elm in production. I'm Richard Feldman, and I work for a company called NoRedInk, and we make grammar and writing software for English teachers. So essentially, we help teachers teach English. We have millions of users, millions of questions being answered per day, and when I joined the company back in 2013, this was our front-end tech stack. We had some Backbone mixed in with some Angular, mixed in with a lot of jQuery, mixed in with a, I'm going to say, more than healthy amount of HTML being rendered on the server. And I don't mean that in a sort of nice static sense. I mean that in the sense of user requests a page, the server figures out what HTML is going to get dynamically rendered on the fly and sends it back. Sort of the best practice PHP circa 2005, although this was Ruby on Rails, not PHP. And this is about as far a cry as you can get from sort of the more modern, typical JavaScript best practice of things like having it be a single page app, which this was not, using Webpack, using React. Actually, React didn't exist back then, or at least it hadn't been open sourced. I remember when React came out because I thought, man, this sounds really cool. This sounds like it would be a significant improvement over what we've been doing. But there was kind of this question of how do we get into it? Because we didn't want to rewrite the whole thing in React just because Facebook said they were using it and were liking it. We didn't even want to make a whole new feature in React because that's a big commitment. If you make your next big feature using this new technology, you don't necessarily know if it's going to work out. Maybe you don't like it. Maybe you get partway through and say, this is not going well. We want to go back to the old way. Or maybe you get all the way through and now you have this one feature in this technology, but you don't like it, and you say, I guess we're just going to leave it that way. Not really a good situation to be in, so it's not what we wanted to do. So instead what we did is said, okay, let's just make a small thing. Just rewrite one part of one page using React. Let's just see how we like it. So we did. We took one part of one page and just rewrote it in React, and essentially it went well. We liked it. We were happy with the results. And so going through this process of building this small thing in React gave us enough information to say whether we wanted to continue using it or not. And because we were happy with it, we said, yeah, we want more. Let's build more stuff in React. And so we started expanding it. And pretty soon we became part of the first class of React early adopters. So we were running into all sorts of early adopter fun problems like documentation being incomplete or inaccurate in various ways and things like that. And after doing this for a bit, we ended up sort of, with a new set of experiences around using React in production. We were able to actually contribute back some documentation changes to Facebook and their React code base. That's beneficial to us. This was very worthwhile. Separately, around the same time, I was doing this side project called Dreamwriter. And I'd been working on this for several years, and I'd accumulated a good bit of technical debt. And I had at some point determined that, okay, I've been doing this functional programming thing a little bit more. I've been spending more time trying to do things in a functional style when I'm writing my JavaScript. React introduces sort of even more of a functional paradigm. And I was saying, all right, I think it's about time that I gave this sort of the full attention that it deserves and just tried actually using a dedicated functional programming language, because now there are several functional programming languages that compile to JavaScript. And I was saying, okay, well, I should pick one and just use it to do this rewrite that I've had planned and just learn about it and see how I like it. And as I was deciding which FP language to choose, around that same time, this blog post came out. It was called Blazing Fast HTML in Elm. And it had this chart on it. This is a benchmark of the TodoMVC application being built and run in various different languages, frameworks, libraries, etc. And I thought, wow, Elm is doing really well. Lower is better on this chart. So I'm looking at it and I'm saying, okay, so Ember, Angular, React, Backbone, familiar with all those. React, I like. React is doing well, but Elm's doing significantly better. And Ohm, which is ClojureScript's wrapper around Elm, or around React, or at least one of them, was doing better than React because it had some benefits it was getting from immutability, but Elm seemed to be getting even more benefits. I was like, wow, this is impressive. So looking at Elm, there were some things that I knew I would like, just based on reading about Elm does these things, I'm familiar with these things, I know I'm going to like them because I already like them. One of them is that Elm does rendering via virtual DOM, same way that React does. So it's this idea of a declarative view where rather than mutating the DOM nodes directly every time you want to update things, instead what you do is you describe how you want the DOM to look, how you want the page to look, and either React or Elm takes care of diffing that with the previous description of how you wanted things to look very quickly. You can do that diff super fast, and then just very quickly apply the minimal set of updates in a very efficient order such that the screen ends up looking the way you wanted it to and everything works out. I knew this was not only part of how Elm got those nice benchmarks, but also something that I was comfortable using, something that I liked using and wanted to do more of. So I knew I'd like that. I also knew I'd like this unidirectional data flow that I'd been used to from Flux. So this is what the Elm architecture uses as well as Flux. And I thought, wow, this is, again, something that I found has been useful. It's been an improvement over the way I used to do things with two-way data binding where I'd get these cascading problems. I said, yeah, I want more of that. I expect to like that because Elm uses it. And finally, I knew that Elm had this sort of concise modern syntax. I'd seen some examples of it. And it just has all these nice things like arrow functions, destructuring, no semicolons. I knew that I was going to like that because Elm didn't have to worry about sort of backwards compatibility with past versions of JavaScript like JavaScript itself does. And it was just sort of free to say, let's just look at what nice language syntaxes look like and let's just use one. So I was looking forward to all those things for sure. But then there were also a set of sort of brand new concepts, these things that I'd never used before in any language. And I really had no idea whether I was going to like them or not. So one was that all values are immutable. Using these persistent data structures under the hood, which is the same thing that ClojureScript and immutable.js do. In other words, when you clone something and you want to change just one thing about that cloned version, it doesn't actually go through and clone the whole thing. It just only makes that one little change. And so changes to immutable data structures in that sense can be very fast. And that's another part of how Elm was able to get such good benchmarks. So I knew that I'd used immutable stuff before, and I'd used immutable.js and seamless immutable, and even just JSON serialization, which is sort of a crude form of getting immutability. And I'd had good experiences when I'd used it in the past, and it had sort of eliminated certain types of bugs. But I'd never used a language where that was the only game in town, where all values were immutable, and there actually were no mutable values. Was that going to be nice? I didn't really know. I'd never tried it before. Second thing was that all functions are stateless. So stateless functions, aka pure functions, aka referentially transparent functions, these are essentially functions where all they do is they take inputs and then they return one value, and that's it. They have no side effects. They don't go out and read from the outside world. They don't go do network requests and database requests, anything like that. It's just same inputs, same output, same return value, and no side effects whatsoever. And I also knew that this was part of how Elm got really nice benchmarks, is that stateless functions are very easy to cache because since all they do is take inputs and return a value, and if you give them the same inputs, they're guaranteed to return the same value. That means that anytime you're calling one of these functions, you can just cache the value that came out. And if you see those same inputs coming through, you don't need to bother calling the function again. You can just substitute in the value you got the last time you ran it, and it's just going to work. Everything's just going to keep working. So I thought, okay, that sounds intriguing. And certainly I've learned that the more stateless functions I write in my imperative JavaScript code, the easier my code base tends to be to maintain. But I'd never used a language where, again, that was the only game in town, where all functions were stateless. I didn't know, how do you do Ajax in a world like that? I didn't know. I knew it was possible. I'd seen demos of it, but I just didn't know how it was done. And finally, I'd heard about this thing called type inference. Now, my experience with compilers that check your types has been basically overwhelmingly negative up to this point. I used to be a Java, C, C++ programmer, and I remember all of these really long compile times. I would say that Scala was probably the worst of all the ones that I did. I just remember just sitting there waiting for the compiler, and when I saw that XKCD comic about the two people messing around and somebody says, hey, why aren't you working? They say, oh, code's compiling. It says, oh, well, carry on then. That was very familiar to me, just waiting for the compiler to do stuff where I just couldn't be working because I was waiting for the compiler. And the other thing I remember negative experience was that all of these languages were very verbose. I would have to write out all of these type signatures, say this is a string, and this is an int, and this is a list. And it just took so long, and just so much extra work, and it seemed like I wasn't getting anything out of it. It was just my code was getting more verbose, and I wasn't getting any corresponding benefit. And yeah, it was nice that the compiler caught some stuff up front, but at the end of the day, stuff would still crash. I still had to test it a lot. I still had to test all my refactors. It was just, it felt like kind of a nice thing, but more of a burden than anything else. So what I'd heard about type inference was that it could be sort of the best of both worlds, where you didn't have this required verbosity because you could write code with no type annotations that just looked like Ruby code, and the compiler would still be smart enough to check all of those and figure out whether or not you were going to do something that was going to blow up at runtime, and just tell you about it at compile time before it could make it to your end users. That sounded pretty nice. I'd also heard that modern compilers are able to be a lot faster than the compilers I'd been used to in the past, so I was willing to give it a shot. Okay, so at this point, it's only one thing to do. Just dive in. I said, I've got some things that I know that I'll like. I've got some things that I really don't know if I'll like or not, and the only way to find out is to dive in and try it. So I did, and at first I just had no idea what I was doing. I mean, I was just brand new to this stuff. I had done some functional programming, but this is a whole functional programming language, and I was just kind of stumbling around in the dark, being like, I'm going to try this, I'm going to try that. But it was a pretty nice language, and as I was, going through and stumbling around and hacking things together, I eventually managed to put Dreamwriter together and get it working. And I said, wow, this works. It's cool. It's fast. And my code base is a total mess because I didn't know what I was doing. But I'd learned some things along the way, so I said, cool, I'm going to do some refactors. So I went through and refactored and moved things around and actually implemented a couple of redesigns that I'd been sort of waiting on. And eventually I ended up with the code base in a place where I was like, okay, this works. I'm pretty happy with this. And then I looked back at the experience I just had, and I realized something pretty crazy, which is that when I'm doing something like that in JavaScript, the experience I'm used to is just that stuff's just breaking left and right, just crashing all the time. Undefined is not a function, my old friend, just all over the place. And when I looked back at all of this crazy stuff I'd been doing in Elm and all of this flailing around and just building stuff, I realized that the entire time I'd gotten no runtime exceptions. Not even one. Not even just no undefined is not a function. Just nothing crashed at all. And this is mind-blowing to me. I was like, there's only one explanation for this, which is that over the course of doing this rewrite in Elm, I have developed superpowers. Because crashing is just a part of life when you're building for the browser. It's just stuff crashes, and then you fix it. And the idea of stuff not crashing and the compiler catching everything, this is not an experience I've ever had. Even in compiled type-checked languages like Java and C and C++, those would crash all the time. But my own code didn't. It just worked. And that was just a new thing for me. I just never experienced that before. So overall, this is just a great experience. I mean, I had a great time. It was really fun. Honestly, I hadn't had that much fun programming since I was 10 years old using Visual Basic and being like, I can make UIs, yay! I just went through this process of building this thing, and stuff just worked. And refactoring it was even more fun. It was just great. I just went and broke a bunch of stuff and said, yeah, this is going to change, and this is going to change, and that's going to change. And I'd go through the compiler errors, and once I'd gotten through all the compiler errors, I brought it back up, and it still just worked. I hadn't even written any tests yet. It just kept working with no regressions. It was great. So then I was at this conference, and the whole weekend I was talking to people about my experiences with Elm and this experience of rewriting Dreamwriter in Elm that had been really positive. And at the end, people would say the same thing, which is that, yeah, that sounds really great. So are you using it at work yet? And this is a reasonable question. If you found something that's really great, why wouldn't you want to use it at work? And my answer was always, oh, no, too soon. Like, we're not ready for that yet. We're not a technologically ambitious company. We're a startup. We got to build stuff. We don't have time to use experimental technologies and, stuff that's brand new. But the more I kept saying this, the more it felt like I wasn't being totally honest. like, was it really too soon? Because I'd had another experience recently that was fresh on my mind, which was this feature that we'd shipped around active voice and passive voice. It was this epic feature that we've been doing at work. And we built it using React and Flux, which was sort of our best in breed, the technologies we've been happiest with on the front end. It was this custom drag and drop UI that had to work on Internet Explorer 9 as well as iPad. We couldn't use HTML5 drag and drop for various reasons. We had to do sort of custom mouse event handling and touch event handling. And we had sort of this repeated iteration after user testing. So one of the things that we value a lot at NoRedInk is efficacy. We really want our product to actually be effective at teaching students. It's not enough for us to just say, okay, our users want this feature, we're going to build it, we're going to check it off the list, and then we're done. We actually go out and test this stuff and try it out with students and see if it's effective at teaching them these concepts. Because we don't want the teachers to pick it up, use it, and then say, well, it didn't work, it wasn't effective. We actually want to be effective. And what we found with this particular feature was that our initial design for teaching this concept just fell flat. We went out and took it out and tried it on students, and it wasn't effective. They weren't learning the concept. And so we went back to the drawing board and redesigned it based on what we'd learned and took that version out, and it's the same thing. It also wasn't effective, but in different ways. And we had to go back to the drawing board several times and make these giant sweeping changes to the code base, to these redesigns, to get to something where it actually worked. And the end result did work. It was pretty incredible. We took it out, and Jossie, our curriculum lead, was teaching middle schoolers active voice and passive voice, which they're not even supposed to learn until high school. But after she gave them about a 30-second primer and ran them through this interface that we'd ended up with, by the end of it, they knew the stuff. They were getting them wrong at first, but by the end, they were getting them all right. It was pretty incredible. But this took months to get out. It took months to ship this. Because through each of these redesigns, whenever I'd be going through and changing stuff, I'd be getting all these undefined, it's not a function, all this stuff doesn't play well with everything else, things are not hooked up right anymore. And you want your tests to save you from this, right? Tests are your anti-regression security system, and they're very effective. I've used tests, to save myself from this kind of misery very effectively in the past. But the problem is, and something that I sort of learned more thoroughly during this experience than I ever have in the rest of my life, is that tests are great at catching regressions for incremental changes. When you change one thing, you rerun your test, and it says, hey, this thing that you thought was still working actually broke something else somewhere else in your system. I'm like, oh, great, thank you for telling me that. Really didn't want that bug to make it to our users. But the problem is when you're doing a redesign, you're changing a lot of stuff. You're breaking these sort of fundamental assumptions that your tests were built on top of. You're moving everything around. What you often find is that in this rearranged world, tests just don't work anymore. You got to throw them out. They just are not effective. You got to rewrite them. Or you either have to live without tests or spend a bunch of time re-implementing them in the new world, both of which are time-consuming. Rewriting tests is sort of obviously time-consuming. And living in a world where you're relying on tests but don't have them written has its own set of problems, because now when you make even small changes as you're going through and trying to finish your implementation, you find that things are just breaking and causing regressions, and you don't really have any insight as to why. And I kept thinking about this experience and contrasting it with the experience I had at Elm, where I would make these huge changes, the same kinds of ones that I've been making in this redesign, and everything would just work. Because I didn't have to write tests. It was just the compiler was catching all this stuff. And it was so good at catching these things that I didn't end up needing any tests in order for my refactors to work. I mean, I would still want tests in general, but when I was doing a redesign or something like that, Elm would just make sure that everything was hooked up right before and after. And I kept thinking about this and thinking, man, if I had gone back and done this whole feature in Elm over these several months, it would have taken me less time to ship it, even counting all the ramp-up time, even counting all the sharp edges we've run into being early adopters. It still would have been a net time savings just because the refactoring experience is so much nicer. So I was like, okay, why have I been waiting for this? Why have I been saying, oh, it's too soon, it's too soon. I need to wait until we have a nice greenfield project, which is kind of the conventional wisdom around this. Why don't I just make a small thing like we did with React? What was wrong with that? Why not just do what we did with React? That worked out really well. We made this small little change that was just very low commitment, very low risk, and we figured out whether or not we liked React. It turned out we did, and we used it more, but if we hadn't liked it, we could have just thrown it out and said, well, that's the end of that experiment, now we know. And so I was thinking about, okay, well, what would that look like in Elm? So the way Elm does interop with JavaScript is essentially, rather than sharing functions with JavaScript or sharing code with JavaScript, it just shares data with JavaScript, much in the same way that you have a client-server relationship where you're just sending data back and forth. So in a similar vein, Elm will send data to JavaScript and will receive data back from JavaScript, and that's it. So this is important because Elm, in order to get nice performance and nice reliability and nice refactoring story, needs to have these certain guarantees in place. Guarantees like everything is guaranteed to be immutable, like all functions are guaranteed to be stateless. Those are important, but of course JavaScript has a different set of rules. JavaScript does not have those guarantees. So if you tried mixing code between the two, you would necessarily lose some of those guarantees that make Elm so nice. And that's why the interop is based on data. You can send data to and from JavaScript the same way that you send data to and from the server, and it doesn't have anything to do with your guarantees. And the way that Elm does this is with this pub subsystem called ports. And I was thinking, okay, so I've got this pub subsystem for interop. Oh, Flux is a pub subsystem, Flux stores. Just why don't I just rewrite one of my Flux stores in Elm? Just pull out the implementation and replace it with an Elm implementation. Seems like it'd be pretty straightforward. Why don't I just do that? That'd be a small thing. I could just pick one of our Flux stores and rewrite it. So I was sitting on this plane on the way back from this conference where I'd been talking to people about Elm and thinking about active voice and passive voice. And I was like, well, I don't have any Wi-Fi. Got a couple hours. Why don't I just do it? So I did it. I just rewrote one of our Flux stores in Elm on this plane. When I got back, showed it to my teammates. They're like, yeah, this is a pretty small, non-invasive change. It's only affecting one piece of our code. Seems like it works fine. Yeah, let's put it in production. So we did. Boom. Month 1 of Elm in production. Okay. So now we've got Elm in production. Now what? So now we have all these unknowns. Like, we like it. It worked. We want to see about using it in other places. But now I've got questions like, well, what's the learning curve going to be like? I'm the only one on the team with any Elm experience. I've been using it for several months. I'm very comfortable with it by now. But nobody else on the team is. What about testing? What's that going to look like? What about debugging? What's that going to look like? We didn't really know yet. So I should mention at this point that the front-end team had grown from one person, namely me, to 3 people. So we had me, Rao, and Aaron, and we were all cats. That's not true. We were not all cats. But we were all working on the front end. We had very different levels of Elm experience. I had several months, and Rao and Aaron were very new to it. Okay, so based on that, it's time to learn some new things. I have to, sort of spread my knowledge around so that Rao and Aaron can, be as productive in Elm as I am. Pair programming was basically exactly how we did this. So pairing is something that we like doing. We've had good results with it in the past. At one point, we did an entire week where we were just pairing the entire week. But usually it's more like 50% of our time is spent pair programming, give or take, depending on the week. And one of the things that it's best for is spreading knowledge around. So that can be knowledge of your code base. It can be getting things less siloed, but it can also be about spreading knowledge about a new technology or a new language, which in this case it was very effective for. That was basically exactly how Rao and Aaron got up to speed, was just by pairing with me and letting them drive, and then I would just explain these whenever they hit something that they didn't know that I did know. We had a pretty nice time transitioning between these because we had this leg up because we already had this declarative rendering architecture in place with React and Flux. These things map pretty cleanly over to Elm because, again, Elm also uses a unidirectional data flow. Elm also uses virtual DOM rendering style. So we're able to pretty neatly just translate from one to the other. And by the way, I highly recommend these. If you can't use Elm for whatever reason, I would say use React and Flux. They're great. By the way, if you're using Redux, you'll have an even nicer time transitioning than we did because Redux is explicitly modeled after the Elm architecture, so it's going to be even closer to a one-to-one translation than what we had. Testing. So we're big on testing. We like to write a lot of tests. Elm test is basically your bread and butter unit test runner. Works just like Mocha or Jasmine. You just give it some Elm code, say I expect this to be this, and then it will run them and tell you if things broke, if any of the tests failed. Karma and Capybara you may have heard of because they're just plain old vanilla integration test systems. So they will run a browser, a headless browser like Phantom.js, something like that. And essentially, when you run them, they will make assertions about the DOM. They'll actually be running the entire thing end to end and tell you about what happens when you do fake user interactions and things like that. We didn't really need an Elm specific version of these. We just sort of were like, well, we have these things that work. Elm code compiles to JavaScript, so these headless browsers can just use that compiled JavaScript code. I don't really see any need to change up what's been working, so we didn't. If it ain't broke, don't fix it. We just kept using Karma and Capybara exactly the same ways we had before. This is one of the unexpected benefits of switching to Elm, was that we could write fewer tests and actually get better coverage. And the reason for this is just sort of that the compiler just gives you a bunch of tests for free, essentially. All of the tests that we'd normally write around null safety and things like that, like what happens if you pass this function a null here? Does it work? What happens if you pass this? What happens if you pass that? All of those edge cases, the compiler just takes care of for you. You don't have to worry about them. Writing a test for them would be kind of nuts because the test itself wouldn't even compile. You sort of couldn't. It wouldn't make any sense. And so we saved ourselves from having to write these tests, and yet we still got even better code coverage than if we had written those tests, because even if we'd written those for sort of common cases that we would expect to mess up, we still would not test every conceivable case, which the compiler actually does. It's pretty nice. Debugging, there are three things that come to mind with debugging. First is debug.log, which we use a lot. It's just basically your bread and butter console.log equivalent. Works exactly the same way that console.log does. Elm Reactor, which is the time-traveling debugger. This is something that I'm super excited about, but we actually can't use it yet because it doesn't support this port system where you do JavaScript interop yet. The next release will, but the current release does not. And because we use ports pretty much all over the place, because there's this whole ecosystem of JavaScript libraries, and we don't want to reinvent the wheel if we don't have to. So we use ports a lot to interact with JavaScript. And we didn't want to have to sacrifice that, so we said, well, all right, we're just not going to use Elm Reactor until it supports that. And then the third thing is source maps. So source maps is something I get asked about a lot because, when you're doing something like CoffeeScript, for example, this is very important because when you get a runtime exception, you want to be able to trace back and figure out where it came from in your actual source code rather than the compiled source code, which doesn't, necessarily look like your original source code, even if it kind of resembles it in a vague way. And this is always funny to me when people ask me that, because I'm like, oh, the source maps are useful for debugging runtime exceptions, but what is a runtime exception? I don't get those anymore. I really don't genuinely know what I would do with source maps if I had them. I'm honestly not even sure I would bother taking the 5 seconds it would take to add it to our build config, because it's like, this doesn't really come up. And by the way, the reason I phrased this the way that I did, what is a runtime exception, is that this is literally a debate we've had on the team. So we have this error reporting system called Rollbar, and one of the things that it does is whenever you get a runtime exception in JavaScript, it automatically logs it, so we can go back and see graphs of this stuff and figure out where our code is crashing in production. And we've been on the hunt to try and find the first case of Elm actually causing a runtime exception. And so we kept having these things where, that was it, we found it. This is it, this is patient 0, this is the first one. Finally, some of our Elm code crashed. And we look at it, and we'd be like, all right, let's go fix it. And then the fix would be in not Elm code. And then, like a little bit later, we'd be like, oh, wait, here it is, look at this. This is an error, this is on this page, I know that page uses Elm, this is it. This one, and then the fix would be in not Elm code. And then finally, we were like, okay, this is like kind of debatable whether or not this should count, but we found a Stack Overflow. It was like, okay, so presumably what happened is somebody wrote some Elm code that didn't terminate. And all right, so like if you have a Turing complete language, that's always going to be a worry. There's the halting problem. You can't catch that up front, even if you have the fanciest compiler in the world. If it's Turing complete, you can do that to yourself. So all right, fine, it finally happened. And then we looked into it, and it turned out it was Internet Explorer choking on decoding a JSON string that was too big, and the fix ended up being make a smaller JSON string. So after 6 months, thousands and thousands of lines of Elm code, we actually still have 0 confirmed cases of Elm causing a runtime exception. I don't even know what to say about that. It's just mind-blowing. It's like we're all superheroes. So that brings us to month 2. More? This has been good so far. Do we want to, dive in and eat more of it? Yeah, it's great. Let's keep it going. So now we're starting to learn what it's like building new stuff in Elm. So previously, originally we just sort of rewritten a small chunk, just this one Flux store in Elm. But now we're starting to build new features entirely in Elm. And in a lot of cases, these new features are part of existing code bases. And so we've been kind of using this as an opportunity to just rewrite more of our code in Elm. We've liked what it's done, and the more Elm code we have, the more maintainable our code base has been. So we're kind of like, anytime we're making a new feature, let's see if we can, while we're in there, rewrite some of the old stuff to be more in Elm. And as a result of this, we've ended up with more features resulting in less technical debt, which is also a new thing. I mean, sort of by default, if you make a new feature, it's adding complexity to the system. Usually you're increasing technical debt unless you're sort of following the Boy Scout rule really closely and trying to leave things in a better state than when you found them, which often involves, writing more tests for other unrelated code in addition to testing the new stuff, which is pretty difficult to do consistently. But we found that just by using Elm more, we ended up with less technical debt, stuff that was easier to maintain even when we were shipping stuff, and what was ending up in production did more than what was on production previously. That was a new thing for us. This is the craziest. We actually had front-end code finding edge cases in back-end code and resulting in improvements to our back-end code. And specifically, this is because Elm has this philosophy of sort of find errors soon. Sooner is better than later. You don't want your errors to trickle through and just cause problems where you have to sort of snake your way back and figure out what the root cause is. Much better to give you an error as early as possible. And part of this extends to the way that Elm deals with data from third-party sources, which could be from JavaScript interop, or it could just be from your server. And so what we had done is we had hooked this up, and we said, okay, so when we get data from the server, Elm is immediately, just automatically for free, going to validate this data and make sure that it conforms to the shape we're expecting. That's just sort of the normal way of doing business in Elm. And when it does, it either says, well, this data was what we expected, or it'll tell you, yeah, this was not what we expected. This is something weird, something messed up. Here's what was wrong with it. And so what we did was we hooked that up to Rollbar, so that every time we got data from the server that didn't conform to the API we were expecting, rather than let that sort of snake through our system and then potentially cause problems down the line, we just reported it to Rollbar, so we surfaced it right away. It's just really easy to do that. And then we'd start looking at our Rollbar logs and we'd see, oh, turns out that actually there were a few cases where the server was not quite conforming to the API that we were supposed to be using there. And our JavaScript code never noticed. It had just been kind of like, well, this didn't immediately blow up, so maybe it'll never blow up. Let's just keep going with it. And that could have caused us problems down the line. Whereas with Elm, it just told us about them up front so we could just quickly fix them and then not have to worry about it causing us problems down the line. And if we do get a problem down the line, we could know that it would never trace back to these API deficiencies. It would be like, yeah, we know our server API is consistent because if it weren't, we would get these errors. We would know about it. Pretty crazy. So then we had some new people join the team, specifically Marika, Tessa, and Stacy. And they all ended up using Elm in different ways. They also all came from very different backgrounds. So Marika, longtime programmer, we hired her to work on the back end, but she's the type of person who really cares about programming and likes learning new stuff and learning good new technologies. And she was just so interested in Elm that she just started working more on the front end just so she could use Elm more, because it's a really cool, really useful, really nice technology. And this is something I never heard of before. I mean, usually when you make a back end hire, they're kind of like typically less interested in front end stuff than in back end stuff, because front end tends to be the land of crazy cross-browser support and things like that. But Elm is just such a cool, exciting technology that this was enough to entice a back-end engineer to want to work on the front end. Never heard of that before. Tessa's background was very different. She went through a coding boot camp, and this is actually her first professional programming job. And so her first week on the job, the fact that by the end of that week she was writing production Elm code on her own, just having no Elm experience coming in, no functional programming experience, just knowing JavaScript, and having known JavaScript for significantly less than a year, it's kind of mind-blowing to me. I didn't realize it sort of could be that easy. Stacy was our designer. We'll get back to her in a second. So this is the first thing that we learned, is that learning gets faster as more people become resources. So back when I was the only one who had significant Elm experience, I was pairing with Rao and Aaron to teach them what I knew. But now Rao and Aaron had significant Elm experience, and they were able to transmit their knowledge over to the new people who didn't have any and were in the same position that they were. So as the team grows, it's easier to spread the language around than it was when there was only one person sort of being the champion and being the one who knew it. Another thing we learned is that JSX is just not necessary. I've sort of heard this meme that one of the things that's really important about JSX is that it lets designers work in just HTML and CSS. You've got the angle brackets, everything's very familiar. But this has always just seemed kind of off to me. This just didn't make a lot of sense. I mean, honestly, it sounded pretty insulting to designers. Like, designers are smart, and they have a very hard job. And I know this because I've tried to do it. I want my stuff to look nice, and I've tried to just sort of pick up visual design. And it's just not something that you can pick up easily. There's a lot of knowledge there. There's a lot of stuff to read. There's a lot of stuff to learn. And applying it is very difficult. Separately, if you know HTML and CSS, that implies that you know CSS. And CSS is a nightmare. It's unbelievably complex. Half of the rules don't make any sense. When you combine them, the result doesn't make any sense. It's just a ton of learning there. And so this just sort of didn't pass a basic smell test. Like, you're going to tell me that someone who knows HTML and CSS and has actually learned enough CSS to be productive in it is then going to be completely flabbergasted, mind blown by the idea of representing the DOM not with angle brackets, but with a slightly different DSL. That's just going to be a bridge too far. Really? I don't think so. And this turned out not to be true in practice. None of us actually taught Stacy Elm. None of us even mentioned it to her. We're just like, hey, we want to make these changes. And Stacy's like, okay. She just went in, started modifying code. It was fine. There was no, problem. She just did it. And by the way that Elm's DSL looks is essentially like this. So this is just plain vanilla Elm code. We have some functions that are just named conveniently so that they will look like the DOM. So you've got a function that's called div, called class, and those correspond to, divs and classes, things like that. We see a number of helper functions in here, like class lists for making a class string out of multiple classes. We've got some custom helper functions that we wrote for splitting our view up into logical chunks like render header, render body, etc. This is all pretty straightforward stuff. I'm not going to go into the details of what all this is doing because there are tutorials you can read online, but you look at this and you can kind of see the structure of the DOM. You don't really need the angle brackets. Neither did Stacy. So that brings us to month 3. We are now Elm early adopters. We're kind of in the same position we were with React when we were React early adopters. We can kind of compare and contrast the two experiences. And man, let me tell you, being an Elm early adopter, way more beneficial than being a React early adopter. But there are definitely some differences. So one of the things we learned is that having Facebook be behind your technology is a big deal for adoption. I mean, it's a big, trusted brand. They have, a large technical team, thousands of employees. When people say that they're using this technology at Facebook, you say, wow, it must be really good. It must be really reliable for them to be using it. So Elm did not have Facebook behind it. Elm had Prezi. So at the time that we adopted it, Prezi had been for about a year bankrolling Evan Czaplicki, the creator of Elm, to just make Elm happen. And the reason they were doing this is that their CTO had been, and some people, some other people in the company had been sort of had this vision of what is the future of the web? How do we make things not just incrementally nicer, but just nicer on a whole different level? We want to make a big investment in that. We want to think 5 years ahead and think, what is the future going to look like? And what's the best future we can have? And what they ended up concluding was that Elm was it. Elm was what they wanted to go for. And so they said, look, we're going to invest in this. We're going to hire this guy, and we're just going to pay him to work on the language, not to work on our product, just to keep developing this language so that when it's ready, we can use it as early as possible. And Prezi is a pretty big company. They got several hundred employees, but they're not Facebook. And so this has some differences. Basically, the main difference is that the early community is just a lot smaller. Stack Overflow is going to have fewer Elm questions answered. The library ecosystem is going to be smaller, and it's going to take longer to grow. I should mention a counterexample to this is the Elm Discuss Google group. really just unbelievably supportive, welcoming, helpful community. Whenever I see someone show up there and post a newcomer question, I'm just kind of blown away by the quality and speed of the response. I'm always thinking like, oh yeah, I know the answer to that. Maybe I'll get around to that in a couple of days. Then when I circle back to it, I see that later the same day, somebody has posted a several paragraph, friendly, helpful response. And I'm just blown away by the quality of people on there. And I mean, you know who you are. You're just unbelievably important to Elm, and I'm really thankful for all the stuff that you do, because anybody coming to a new language really deserves that level of treatment, and I'm really glad that Elm has it. So one of the other things that we ran into as early adopters is some of these sharp edges. So we use Jenkins for continuous integration. It's our build server. And this is essentially a simplified version of the script that we use to run our Elm code and our Elm tests on Jenkins. So first we install Elm and Elm test with npm. Okay, that's pretty straightforward. We'll get back to that second line in a second. And then we just run the Elm test with a bash script and see what happens as far as whether they all pass or not. Now that second line was something that we had to kind of find out the hard way. This is something that we were only able to reproduce on Jenkins. Haven't seen it happen on Travis or AppVeyor or any other build system, and only on one of our two Jenkins boxes. We still don't quite know why this happened, but basically we were getting an error, and the solution ended up being exporting this fairly obscure environment variable to force it to use UTF-8 encoding. Now this is the type of thing where when you run into the error that we were running into, with an established language, you expect to just kind of Google it, and then somebody has already posted, the workaround, and you just use that workaround and you move on with your life. But of course, being early adopters, we were the first ones to run into this, or among the first, and so we couldn't just do that. We actually had to, work with community members to figure out what was going on, figure out what the solution was, and then implement it. And this took significantly more time than if we'd been using an established language where we could just Google it and just get on. That's nothing compared to our experiences with the Rails asset pipeline, and mistakes were definitely made there on our part. So although we were not the first ones to use Elm in production, we were the first ones, as far as we know, to use Elm with Rails in production. And so we had to come up with some stuff from scratch. We had to build our own Sprockets integration. We had to figure out how integrating with the Rails asset pipeline worked ourselves. And what we discovered was that there were some important differences between how the asset pipeline works when you're deploying to a server versus when you're just using it for local development. And we had stuff where I was like, yeah, this works locally, so let's just go ahead and deploy it. And it seemed like everything was working fine until we ended up with symptoms like, well, wait a minute, this code worked locally, but it looks like the change didn't make it to the server. Like what's in production doesn't match with what's in our code base. So some of the stuff didn't get successfully deployed. It looks like Sprockets didn't figure out that it had changed, didn't think it needed deploying. Uh-oh. So we had some sort of surprises, and this is again a case where being early adopters, cost us more time because we had to figure these things out the hard way and, sort of run into these sharp edges because nobody else had run into them and blogged about them or posted on Stack Overflow, etc. But there's a flip side to that, which is that when you're the first ones running into these things, and you do have to, build certain things from scratch rather than just reaching and having it be there off the shelf, you get a lot of opportunities to contribute open source. And that's something that we like at NoRedInk. That's something that is valuable to us. We feel good about the fact that we give back to open source, and it's just sort of one of our values as a team. And there were a lot of them there because we were the first ones using Elm with Rails. So we made an Elm Rails helper library that makes it nicer to work with Rails directly using Elm functions. We had that Sprockets initializer, which we've open sourced. And we even had some non-Rails stuff, just the fact that it wasn't out there and we wanted it to exist. So we had some string manipulation stuff that we open sourced as well. Okay, that brings us to month 4, maintaining Elm code. So one of the differences between Elm and JavaScript that's most pronounced is that corner cases are brought to light immediately. So catching errors early rather than later. And the compiler will tell you about these up front, and you sort of have to fix them up front. And that is a bit of a double-edged sword, because on the one hand, yeah, they're stopping errors from reaching production, but on the other hand, it takes longer to get the same code to demo. And if you think about it logically, if you've got two different paths, and on the one path, you don't have to fix corner cases, you can just go ahead and just assume they'll never come up. And the other the other path, you're told about the corner cases and you have to fix them. Well, sure, it's going to take longer to address those corner cases up front than it would if you could just ignore them. Now, granted, if you're going all the way to production, ignoring corner cases is going to get you in trouble because stuff's going to break and it's going to take a lot longer to fix than if you just dealt with it up front. So the net result of all this was that we found it was taking us longer to get something up and running for a demo, but it was taking less time overall to get the feature from start all the way into production. That's going through QA, going through testing, all that stuff. Because all these corner cases were caught up front, we just wouldn't have as many things to fix after it had made it to our users or to QA and to go back and have to fix those by diagnosing the problem. Instead, the compiler would just tell us about all these edge cases up front. We'd fix them up front, and they just never would make it that far to begin with. So here's an example of that. Here we're calling a function called getFullName, and we got this fairly standard-looking record here, but there's actually a bug here. We made a typo. If you look down where it says phone number, it doesn't actually say phone number. It says phone number. We made a typo. And in JavaScript, what's going to happen if you do this is everything's going to be fine. It's going to compile. It's going to run. But then sooner or later, you're going to do something like running a regular expression on that phone number string. But because you're going to say user.phoneNumber and not user.phonenumber, you're going to say user.phoneNumber.match. What you're going to get is that there's no method called match on undefined. You're going to say, oh, user.phoneNumber is undefined. Why is it undefined? And so you'll go and you'll bring up your console. You probably set a breakpoint and then add a watch for user.phoneNumber. And sure enough, it's going to be undefined. You say, yeah, great. Okay, so let's step back and figure out why it was undefined. And you step back and step back and step back and sort of navigate backwards through your code until you eventually get to the point where you see, okay, wait, it was defined here. And then after I called this function, it didn't get it. It was undefined. Oh, typo. Ugh. And you slap your forehead and feel like an idiot. You're like, God, why couldn't it have just told me about that? Why did I have to spend all this time? I mean, it's going to spend hours. In Elm, this error takes less than a second to identify. And the reason I say that is because the compiler is going to catch it. And usually when we run the Elm compiler, it takes less than a second to run. It's very fast, and it's very good at figuring out only the things that it needs to recompile. It's pretty much as far as I've ever gotten from that old experience of compilers taking a long time. Less than a second, you're going to see this. Function getFullName is expecting the argument to be something, 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 phone number, other stuff, but it is something, 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 phone number. Hint, I compared the record fields and found some potential typos, phone number and phone number. So it just directly tells you what the problem is. It just goes straight to the conclusion and says, look, this is what's wrong. That's amazing. That's how this ought to work. And I cannot tell you how much time having this has saved us. All of these cases where we would have spent a bunch of time tracking down at runtime why something was undefined, why something didn't work, and instead having the compiler tell you in less than a second, here's what the problem is, has just saved us such a huge, mind-blowing amount of time. It just dwarfs whatever initial setup time we had to get Elm going in the first place. It's been unbelievably good for us. The net result of all this is that scaling is just really nice now. Stuff is easy to refactor, it's easy to make changes, it's easy to introduce new stuff. Even our most complex Elm UIs, and we have some very complex Elm UIs, thousands of lines of code. Even those most complex parts of our code base are more resilient to change than any of our React UIs. Like if you say, all right, Richard, you're going to have to make a 100-line of code change, and it's either going to be to some of your really nicely written React code, or it's going to be to any of your Elm code, the most complex, the most crazy stuff going on, the absolute, thing that you would least like to touch in your whole code base among your Elm code base. Which would you rather have? The most complex Elm code base has the change, or any React UI, even the nicest React UI? I'm immediately like, oh, Elm for sure. It's not even close. It's not even something I have to spend time thinking about. Because the compiler is just so good at catching this stuff that I am just completely confident when I make changes. I don't have to worry about nearly as much stuff as I have to worry about when I'm dealing with my React code. It's fantastic. So one of the things that people have asked me about a lot is they're like, okay, but the reason that Elm is nice is because of these features like immutability and stateless functions and type checking, type inference, virtual DOMs, unidirectional data flow. And they say, look, why would I want to learn a new language for that? I can get all that stuff in JavaScript. I can use Flow to get type inference. I can use immutable.js to get immutability with persistent data structures and all the same speed kind of characteristics. I can use React for virtual DOM. I can use Redux for not only unidirectional data flow, but even the exact Elm architecture. And I can use Babel to package it all up in something that has nicer syntax, like destructuring, arrow functions, those same types of things. So why would I bother learning a new language to get all this stuff? And the answer is that we know better than that. We know that if you just take two products and you just compare them with feature checklists, that gives you a very inaccurate picture of what it's going to be like to actually use them. There are differences in user experience that go way beyond just feature checklists. In particular, some products are more than the sum of their parts, and some products are just not designed to capture the synergies there. They just sort of work together and they have the features checked off, but they're not more than the sum of their parts. And I can't think of any better way to visualize the way that I think of these differences than this. Which of these would you rather have? I mean, yeah, okay, like the thing on the left has those features checked off, but man, you are going to get a much nicer experience using the iPhone. Just trust me on this. It's going to be better. And there are concrete examples of this. Here's one. So I got this survey recently that said, how do you prefer handling client-side dependencies? And had a couple of different options. These are all things I've used. I've used NPM quite a lot. I've certainly used bespoke script tags a lot. I've used Bower a lot. But what I put in was Elm Package. That is how I prefer to handle client-side dependencies. So Elm Package is Elm's package manager. It's like it's equivalent of NPM. But it works a good bit differently. Here's one of the ways that it's different. You can run this command Elm Package diff. You give it a package and then two different version numbers. And it'll just run a diff of the API and tell you what changed. Like before you're contemplating this upgrade, you can just see an exact diff of the API that changed. It'll say, okay, here's what changed. This is a major change. And saying the HTML.attribute module changed. IsMap used to be a function that took a string and returned an attribute. Now it takes a bool and returns an attribute. Preload used to take a bool and return an attribute and went the other way. Now it takes a string and returns an attribute. So I can see these things for any two different version numbers because Elm Package is aware of the APIs of every single package in the repository. And it actually gets much cooler than that. So it says this is a major change. But it's not inferring that from looking at just the major version number according to semantic versioning. It actually knows this is a major change. This is a breaking change. And it goes one step further. It actually enforces that. It enforces semantic versioning. So if I'm working on Elm Rails and I try to publish this version where I made a breaking change, but I didn't update the major version number, I didn't increment it, this is what I'm going to get. I say Elm Package published, say, okay, and verifying. It says error. Looks like you're trying to bump from version 2.0.1 to 2.1.0. This implies that you're making a minor change. But when we compare the 2.0.1 API to the API you have now, it seems that this should really be a major change. Run the following command to see if the API diff are working for you. It tells you to run Elm Package diff. It actually won't let you publish a breaking API change without incrementing the major version number. And this is true of all packages in Elm Package. And what that means is when you're getting a new version of a package, you actually know that it's following semantic versioning because it's being checked automatically every single package. And so what this means is you never have cases like in the past year, there was a breaking change. Underscore.js released a new version where it was a minor version bump, but it actually had breaking changes. A lot of people got burned by that. You can't have that in Elm Package because if you try to do that, it won't let you. So you actually have reliable semantic versioning across all the packages in the entire ecosystem. It's incredibly nice. But more to the point, can NPM ever have that? Is that a feature that NPM can add? Semantic versioning automatically enforced across all of NPM? Of course not, because in order to do that, you have to have a package manager that's not only aware of all of your libraries being type checked and how their types work out, but they also actually have to be type checked, and JavaScript is not. So this is just always going to be out of reach for NPM. Even if it sounds nice, even if it's something that we wish we could have, we never will have it because you need these guarantees. You need a language that is more than the sum of its parts. It's more than just a feature checklist. It's about once you have these things and you know that they're true across the whole library, what can you do with that you couldn't do before? And Elm is really big on taking advantage of those things that you just can't do in JavaScript. And over time, as Elm grows and grows, the list of things that you can do in Elm that are just not possible in JavaScript is getting bigger and bigger. That brings us to month 5, the Python paradox. So the Python paradox is an article that was written about a decade ago, back when Python was sort of a new, fancy, hot off the presses technology. And it had this reputation for being nice, but it was also pretty big risk to use it because not a lot of companies were using it yet. It wasn't, very widespread yet. And the paradox was about this sort of intuition that you would have where you're like, well, look, I can't use Python. It's this new thing. I'm not going to be able to hire anyone. Nobody knows it. Very few people are familiar with Python. And yeah, they can pick it up on the job, but how am I going to be able to hire people to use a language that's just not widespread yet? There are millions of Ruby developers out there. Why don't I hire them instead of trying to use this newfangled thing? And it's the same argument you hear today. Why would I use Elm? I'm not going to be able to hire anybody. There's not that many people know Elm. And the reason it's called the Python paradox is because, paradoxically, using a new technology, if you're trying to hire great programmers, is actually really beneficial, or so the article claims. The idea is that, okay, yes, there are not a lot of people in the world who know Python, but among really great programmers, a lot of them are just really interested in new technology and using the sharpest tools they can find and using the nicest languages, and they're willing to learn. They might either know a little bit of Python already, or they might be willing to learn it on the job. In fact, they might even be excited about learning it on the job. And in fact, using Python might be a way that you could attract great programmers to work at your company. And so you might actually have an easier time hiring if you did use Python than if you didn't. That's the idea. Does this hold true for Elm? Actually, yeah. It turns out a lot of great programmers want to code in Elm because it's a really nice technology. And so ever since we've started using Elm in production and telling people that we've been using Elm in production, we've had a flood of applicants, and they consistently cite getting to use Elm as the reason they apply. They say, we want to work for you guys because Elm is awesome, and we want to come here and use Elm. And actually, some of our most recent hires have been because of this. Noah and James both came to us and found out about us because of Elm, not because of the other stuff we were doing. Noah is one of the best front-end programmers I've ever worked with. He's a contributor to Elm. He's just a phenomenal guy. I feel kind of embarrassed by his productivity, and he's just been a wonderful addition to the team. And James is actually a back-end guy who came to us because of Elm. James is one of the oldest members of the Ruby community, James Gray. He's he wrote the CSV library for Ruby. And the reason he came to us is not because we're doing Ruby on Rails, because there's a ton of companies doing Ruby on Rails. It's because of Elm. And the other addition to the team, I left a little blank there. Your name goes there. You should apply. We're still hiring. We're looking for great programmers, and please take the time to apply. We would really appreciate it. And finally, that brings us to month 6. So this is our current breakdown of Elm to other stuff on the front end. We start off with just CSS, HTML, JS, and CoffeeScript, and now Elm has made a 17% dent in that over 6 months. This is after a 3 to 4 year old code base, and that's growing all the time. That 17%, because our front end team now writes Elm basically 95% of the time, including 100% of new features. Anytime we make a new feature, we always do it in Elm, and anytime we're making a significant change to an older feature, we always try to rewrite it in Elm if we can, because it's going to end up being more maintainable afterwards. So that other 5% is basically distributed between, okay, yeah, sometimes we have a quick bug fix in some legacy code, and it's not going to make sense to rewrite it when it's just a couple lines of code to change to do the fix in JavaScript. And then, of course, doing JavaScript interop, because as previously mentioned, Elm doesn't have a huge library ecosystem yet, but JavaScript certainly does. And so there are a lot of cases where we'll say, yeah, we don't want to reinvent this. It's not available off the shelf in Elm, but it is available off the shelf in JavaScript. So we're going to write a little bit of JavaScript to interop with JS and just use that existing library. But 95% of the time, we're just writing Elm code. So I would recommend that you go for it. If you're thinking about it, give it a try. And do it the way we did it, by making a small thing. Don't wait for a greenfield project. Don't wait for some big new feature. Just do something that's not risky. Just make a small thing. Just introduce it to your code base incrementally, same way we did with React, same way we did with Elm. Works out really well, and if you don't like it, you didn't risk a whole lot. You just spend a little bit of time making a small thing, and if it doesn't work out, you say, okay, that's the end of that experiment. Move on. If you'd like a walkthrough on how to do that, we actually have a blog post on our company blog that talks about how to do exactly what we did. Take a Flux store and rewrite it in Elm. And it specifically walks through the TodoMVC app built on Flux and rewrites its store in Elm, so that by the end of it, you end up with TodoMVC in Flux, except using Elm for the store instead of JavaScript. And finally, if you're interested in just getting into Elm in general and you have a JS background, we have another blog post that's just building a live validated sign-up form in Elm, and it assumes only JavaScript knowledge. Going in, no functional programming experience, no experience with immutability, stateless functions, Elm, any of that, just JavaScript. And by the end of this blog post, you will have built a live validated sign-up form using Ajax and all that good stuff using Elm from start to finish. So I want to leave you with this. If you're thinking it's too soon, you're thinking, we're not ready, we're not ambitious enough to try this out. It sounds nice, but we're not ready. I want to just leave you with this quote from our director of engineering, which is what he said when he found out I was going to be giving this talk. If we could travel back in time, what would we do differently? Make sure you add "done it sooner" to the list. Thanks very much.
Awesome, man. Thank you so much. That was super informative. I want to make sure we have as much time as possible for questions. And I thought, since there's a bunch, there's about a dozen in the questions section. This is your call out to ask your question in the questions section there. But I thought we'd start with one from that we got over email, if that's okay.
Yeah, real quick. I'm gonna Noah Hall is one of my coworkers, and he's actually on the call. So I just added him to the organizer list and unmuted him. So Noah, if you want to say hi and just tell people a little bit about your background, you can dive in and answer questions as well.
Can you guys hear me?
Yeah.
Okay. Hi, I'm Noah. I'm the most recent hire at NoRedInk, at least on the front-end team. My background is that I used to be a researcher, and I was doing research in Elm. I used Elm in production briefly before going to NoRedInk, and well, I love Elm. That's basically it.
So the question over email was, when you find yourselves having to use JavaScript, are you trying to write it in a purely functional way? And how do you deal with state where some of an app is Elm and some is JavaScript?
So to the purely functional part, I would say no, which is pretty much because if we could write it in a purely functional way, we'd just leave it in Elm. Really, the only time that we're ever writing JavaScript is when we're having to do some sort of interop, and usually JavaScript libraries tend not to be written in a purely functional way. So we just kind of use whatever the library wants. As far as how do we integrate it, JavaScript and Elm on the same page, basically, so Elm can just render to a single DOM element, like a single div on the page. And so typically the way that we'll do that is we'll just have one piece of JavaScript code. So maybe most of the page is in JavaScript, let's say, because this is a legacy page and we haven't rewritten it in Elm yet. Most of the page will be in JavaScript. One of the lines of JavaScript code we'll add to that page is render an entire Elm app to this one little div. And if we need that one little self-contained Elm app to communicate back and forth to the rest of the page, we'll do it using ports. So we'll set up the handlers right there, right after we tell it to render to that div.
It's also good to point out that we use CoffeeScript a lot. So that's kind of nicer for writing functional stuff in JavaScript than just plain old JavaScript.
Yeah, true. That's what we did before we switched to Elm, was we would kind of write CoffeeScript in a functional style, because CoffeeScript has arrow functions and everything is an expression and nice things like that.
Cool. The rest of the questions are in the questions tab, and I think the ones that were asked first are at the top. So do you want to dive into any of those? I figure it might be easier for you to read them than for me to read them out loud.
Sure. Noah, can you see those?
Starting with a smiley face, yeah.
Yeah. Okay. I don't think there's much to say on the smiley face one. Some of these are about the.
I cleared a bunch of those off, but the first one I see is from Nicholas Fernandez.
All right. Let's see. Oh, I see. Okay. But learning Elm by helping build features for the Elm package site and publishing some libraries. And notice that, like you said, the compiler effectively works as a regression and basic test set. Totally true. In your experience, what's a good balance for reliance on the compiler and coverage with unit tests? And which approach and scope do you find is more effective for unit tests? Yeah, that's a great question. So generally speaking, my instinct is to write tests for business logic and let the compiler worry about all the wiring. So essentially, I no longer worry about, like, is this thing calling this other thing properly? Is it passing sane values? Any of that stuff. When I'm writing a unit test, it's just about business logic. So for example, when this value comes into this function, what value do I expect to come out the other side? That's something that the compiler can't check is working properly. If you have, you're doing a calculation wrong, or you have some, if statement that's not quite, the conditional is not quite right based on what you want it to do, that's stuff where tests are great. And when it comes to wiring, and a surprising amount of JavaScript errors come from the wiring being wrong. That's where I just leave it all to the compiler and don't write any tests and never get burned by it because the compiler is really good at catching those things.
Yeah, it's definitely down to, like, if you've got a bug in Elm code, then the bug is just going to be logic if it's not caught by the compiler. That's the benefit of having a compiled language with static types, is that it can guarantee you things that if you didn't have a compiler, that it wouldn't be able to guarantee you things.
Yeah. Okay, next question. Have you looked into or used Elm Check, which is claim-based testing? If so, what are your impressions? Yes, we actually use that in production too. Yeah, I mean, impressions are that it's like a pretty nice, straightforward property-based testing. Essentially, if you're not familiar with property-based testing or quick check style testing, the idea is that rather than writing one test case for a particular thing where you just have one set of input values and then you make an assertion about that on the other side, instead you write sort of a description of how to randomly generate tests and to set those so that once you run your test, it's going to randomly generate a bunch of inputs with a certain set of constraints. Like, I want a string for the first argument, and I want an integer for the second argument. I want to make an array of this and that for the third argument. And then you just run like 100 or 1,000 tests with those randomly generated values. And the idea is that it helps you discover edge cases in your logic. So we use that a lot more for things where we have sort of open-ended, like a lot of different possible values than we do for just general code. So kind of strangely, I actually think that quick check style testing is a lot more useful in JavaScript than it is in Elm, because in JavaScript it lets you catch edge cases like, what if this thing is undefined? What if this thing is null? What if this thing is not a number? Are you going to get crazy answers? And whereas in Elm, because the compiler is preventing a lot of that stuff up front, you don't have to care about testing null, undefined, etc. And so basically, we use Elm check actually less in our Elm code than we do like quick check elsewhere in our code base, which is kind of funny but true. Okay, what about build systems? I heard you were working on the Webpack loader for Elm. Actually, both of us are. What is the current state or future plans? So we recently released Elm Webpack Loader version 1.0. It's ready to rock. You can use it right now. Early impressions seem to be that it works well. Like I said at the beginning of the talk, we're not quite using Webpack in production yet, but we're working on transitioning to it. And so as we get more experience using it in practice, obviously we will contribute back and continue making improvements to that. I know that there's also an Elm Grunt plugin, which I wrote, but have honestly not maintained much recently because we're moving to Webpack. Somebody else wrote a gulp plugin, and so all of these are just different ways to do that. There's also the Sprockets initializer that we open sourced. So as far as I know, all of the major build systems are covered, but I don't have as much experience with all of them as I do with Webpack and Sprockets.
Yeah, Webpack's ready for production now, so go ahead and use it.
Yeah, definitely. Next question. What is holding back Prezi from using Elm now? Nothing. They are using Elm. They're just not using it all over the place yet. They're using Elm a very little bit, and this is a relatively recent development. But it's Prezi is a large organization. They take a long time to make changes relative to a small, nimble startup like us, where we can just have one guy write some code on a plate and say, hey, let's use this in production. That's just the end of the discussion. We just say, yeah, seems good, let's do it. And this has actually been a pretty consistent pattern, is that larger companies, even ones that are as big believers in Elm as Prezi is, just tend to take longer to have organizational change than smaller companies, where you can just have kind of a quick meeting and say, hey, this seems like a good idea, let's try it out on a small thing. So Prezi did do this small thing approach, but they're still at that stage. They haven't expanded their use as much as we have. How complex is it to create reusable input components in Elm, e.g. a date input component that formats the date when the user switches to another input, blur? Yeah, so this is a great question, because this is sort of an ongoing debate. There are a couple of different strategies you can use to make reusable components in Elm. I like to think of them as a sort of a heavyweight approach that takes longer to write the component, but makes it more modular and easier to consume. And then there's a more lightweight approach where you essentially don't bother letting the component have its own state, and you just say, I'm going to keep all the state myself. I'm just going to use this as a reusable view function. And depending on which approach you go with, you get sort of a different set of trade-offs. So I can tell that this question is from someone who's used Elm before, because this is one of the things where currently it requires a little bit of JavaScript interrupt to do it, because there's no mutation in Elm. There's no way to just say, hey, when this happens, I want to imperatively refocus the screen on this particular input. So the way that we do that, when we want to do something like that, is we just use a port. It's like a very tiny amount of JavaScript code. We say, hey, when this happens, send out to a port, and then the port will just, all it does in JavaScript size is like one line of code that says, blur this one thing or focus this one DOM element. So nobody's written like a general production-ready, reliable way to do that in Elm yet for stuff where you want to directly interact with the DOM. It's totally doable, and actually Noah can probably talk a little bit more about that, because he did a little bit of work on a sort of jQuery and Elm type thing that would let you do these things in pure Elm. But the short answer is, when you're doing interactions like that for now, there's no official, well-supported way to do that. It's just very experimental. But the good news is that, whenever we run across cases like this, where it's like, okay, the Elm libraries ecosystem has not made a first-class, wonderful way to do this yet, you can always fall back on ports. You can always just say, yeah, we're just going to have one more, and we don't like to, because we're like, oh man, we're dipping back into JavaScript. We'd rather have everything be in Elm. But at the same time, man, 99% Elm, 1% JavaScript is just so much better. It's not even close. So, when you want to do something like this, I would say either decide if you want to do the heavyweight component style or the lightweight component style. Usually we tend to just use the lightweight style, and that's fine, and just sort of faster. And if you want to see examples of that style, by the way, you can look. We've open sourced some of our Elm components that we've made. It's called Elm-HTML-widgets. It's on GitHub. And then if you want to see examples of the heavyweight style, if you look at Startapp is this sort of nice library for organizing your Elm code that's sort of standard way. And it has examples of how to use it in a nested way with this more heavyweight component style. So either of those you can find examples of them on the internet. And if you want to find examples of using ports to do stuff like blur, where there isn't an Elm library that directly interacts with the DOM yet, you can just search for Elm ports, and there's an article on how to use them. Okay, can you speak to browser compatibility in Elm? Yeah, it's great. I mean, the only cross-browser issue we've ever had was when we were using a library in Elm that relied on request animation frame, and we didn't have it polyfilled for Internet Explorer 9, so all we had to do was just add a polyfill for that, or a shim, I guess. That was it. Like, as far as the general JavaScript that it outputs, it's not using even any ES5 features like, array.map or anything like that. So it's just very good at cross-browser compatibility.
Yeah, I can't think of any time where I've had any issue with it not working with a particular browser.
Let's see. Okay, is it your destiny, this is a Star Wars reference, to not fully escape the pull of the compile star? The tractor beam. What is the wait time going from Elm to JS? I'm not quite sure if this is a question about compile time or
Yeah,
I guess it is. I'm gonna proceed assuming this is a question about compile time, and I guess the question is essentially how does it compare waiting for Elm to compile versus using JavaScript where there essentially is no compile time. Okay, let me tell you a little story about that. So one time I was working with Rao. We were working on a feature and we needed to make a pretty substantial change to some of our Elm code to implement this feature. And so we did. We went through and spent like half an hour making changes and just sort of hacking everything apart. And then we spent like the next hour after that fixing all the compile errors, essentially resolving all of the stuff that we'd broken. And at the end of it, we finally got it all compiling, and we went over and brought up the browser to refresh the page finally and see the results of what we'd done and try it out. And we were both looked at each other and were like, wow, refreshing the browser is so slow. Like, waiting for an entire page load, which takes like hundreds of milliseconds, oh my god, is this slow compared to waiting for the compiler to give us an error. So we were both just like, wow, compiling is just actually a huge time savings in Elm because you get the feedback in less than a second and like even faster than a browser page refresh. Like, in JavaScript, you'd refresh the page and then bring up the console and look to see if you've got a runtime exception if things aren't working right. Whereas in Elm, almost all the time, you're just getting compiler output like that, just instantaneously. And it was just kind of a funny moment. We just like laughed about it because we're like, wow, this is actually just much faster than doing it all in the browser would have been.
So, something to add to that. The first time that you run Elm Make, which is Elm's compiler, it'll be pretty slow because it has to go through and compile all the packages by default. But once you've run that once, it will cache all the files, and if they're not modified, then it'll just use the same output code again and again, which basically means you only end up actually compiling a single file. It's not like with like some older compilers where it'll compile all the files every time. It will just compile the file that you changed.
Yeah, that's true. Like the first time I'm cloning somebody else's like Elm project from GitHub, the first time I build it, it'll take like multiple seconds, like always less than 10 seconds, but like I'll actually watch a progress bar. But then after that, it's always instantaneous. So that doesn't really come up much at work because I've always just got the local. I'm never like cloning my work repo from scratch and then building from scratch, so I forget about it at work. But yeah, it's true. The first file does take several seconds.
Hey guys, we've got about 10 or 15 minutes left, so I thought maybe we'd skip to Vincent's question. I saw the NoRedInk take-home repo. Any move to the server side in Elm in production planned?
Noah is the guy to talk to about that.
Okay, so those of you who don't know, the take-home repo is a experimental repository that I've been working on, creating full stack Elm. So what we mean by that is server-side Elm, CSS in Elm, build tools in Elm, all kinds of things in Elm.
Also the front end in Elm, just in case that wasn't clear.
So we're actually planning to use that in production. It's not quite in a state where we're ready to use it in production yet, but we're going to use it basically for managing people who apply to work with us. We're going to use it for giving them our take-home. That's why it's called take-home. It's pretty close to being done. all the server stuff is basically there. All that needs doing is cleaning up the CSS, and doing a few live stress tests on it. Once those are done, then we're going to be using it in production, and we'll probably make an official announcement about it then. But probably not until that work's been done.
Cool. And then it looks like Tom asks, can Elm be used with React Native? And is so, is Elm viable for creating native module apps using React Native?
So there are some other people who have done this. Andre Staltz, creator of Cycle.js, and one of his coworkers. They're both really into Elm, and they built a proof of concept of Elm compiling to and working with React Native. But at this point, it's just a proof of concept. I would definitely say, and I think they would back me up on this, that it's not intended for production use yet. It's mainly just they kind of got like hello world and some basic interaction going to show that it works. And it's certainly not fleshed out as far as a library ecosystem. But yeah, it definitely works, and something to keep an eye on.
There's also a couple questions about how you handle packages you don't want to publish or private repos.
Yeah, essentially, so that's an upcoming feature that's planned for a future version of Elm Package, like basically being able to depend on other packages, not using Elm Package, but rather just using like local dependencies of some sort. It's like a well-known thing that everybody wants to exist. It just hasn't been written yet. So for now, the workaround is essentially that you can specify source directories, like multiple source directories in Elm Package. So if you just literally clone the other repo and add it as one of your source directories, it works. It's obviously not as nice as having just being able to point it to a URL or to a point on the file system, but there is a pretty straightforward workaround in the meantime.
We haven't had to worry about that too much because anything that we can publish as open source, we have, so we haven't really needed like private things.
There's another question right now. Evan is an important figure in Elm, and he does a great job, but are you concerned about having a single point of failure? Lots of pull requests are open for a long time. How do you see Elm developing in the medium to long term?
Yeah, that's true. First of all, I'd be very sad if, Evan got hit by a bus or something. That would be a huge bummer. But I think actually having Evan, sort of being the benevolent dictator, has definitely overall been a very positive thing for Elm. Like, it's true that, he's incredibly busy guy. Like there are definitely pull requests that stay open for a while because he just doesn't have time to review all the pull requests and work on new features and manage the community and speak at conferences and write blog. I mean, there's just a ton of stuff that he's doing. But at the same time, I also know that Elm has really benefited from having him as this, one voice of, how to do things. And the reason I say that is because Evan, I mean, I've talked a lot with him because he's actually in San Francisco, so we go to the Elm meetup together and we chat a lot. And I happen to know that he is one of the most unbelievably well-versed people in programming language design in the world. I mean, he's read all the academic papers. He's looked at all the stuff that's going on in industry. I mean, he's just got all of these things in his head. And the result of that is that he's got this vision that I just keep having this experience over and over where I'm like, I think I've got a great idea for something that's going to make Elm better. It's going to solve this problem I've been having. And I'll talk to Evan about it, and he'll be like, I thought of that. Here are 3 things that you didn't think of. I'm like, oh, yeah, I didn't think of those. And then he says, here are the drawbacks. Here's what I'm planning to do instead. I haven't gotten to it yet, but here's what's on the roadmap. And I'll say, wow, that's way, way better than what I came up with. And Elm has just really consistently benefited from having him in that position and just using all of this knowledge that he's, accumulated over the years and reading all these papers. And, he cares a lot about usability and all these things. And just having one person who can, do that and be the voice of reason and say, this is what we're going to do, this is how we're going to get things to a nice place, has been really, really beneficial. And when I compare like the Elm ecosystem to like something like NPM, like it's definitely true that NPM has a much bigger community, things move much faster, but it's also true that in the world of NPM, you have, just a ton of fragmentation and a ton of, different people kind of like tripping over each other to implement things. And as a newbie coming to both, you're kind of struck in Elm by like, oh, there's just kind of like one nice way to do things, and it's great. Whereas in JavaScript, you're always like, okay, I don't know which of these 5 libraries to use. I don't know, what's going on here. And a big part of that trade-off and how Elm has been able to get that way is just Evan being the gatekeeper and saying like, leading the way and saying like, this is how we're going to do things in Elm, and just having that one voice. So yeah, I mean, there's a trade-off of having a single point of failure, but overall, I think it's been definitely beneficial.
There's also a lot of discussion right now about how best to structure the ongoing Elm community work, progressing Elm as a whole, rather than just Evan doing everything by himself.
Yeah, sort of like how can we get community members to contribute in a way that is, going to keep moving things forward and keep all the good things we've been having going without, sacrificing the nice things that have happened as a result of Elm being, sort of the one captain of the ship, as it were.
Let me see if I can cherry pick a couple more questions. David
Sure.
asks, do your standalone Elm apps that are embedded as a particular div read right back to the same store as the JS React components?
I don't think we've ever specifically done exactly that. There's no reason they couldn't. I mean, you could have, the state stored in React code in Flux, and just use ports to have, that store update and send data over to Elm whenever the store changes, and likewise have Elm, send inputs back to corresponding store methods. No reason we couldn't do that. We just really have not had a use case where we wanted to yet.
I've done that before on a previous project, and I prefer having the state in Elm rather than React or Flux.
So maybe this is a good question to end on. How do you compare Elm with other similar languages like PureScript, Haskell-based languages? We see tools that change C# to JavaScript, Scala to JavaScript, Groovy to JavaScript, etc. One thing that bothers me is with all these languages, will Elm be lost in the mix?
I would say exactly the opposite. Especially, so I actually started off on PureScript and then ended up on Elm. So a lot of the languages are just sort of out of the running because they're not really, emitting compiled JavaScript that's sort of like usable in production because it's just so bloated and slow. So I've actually spent a lot of time researching different languages because, like I said, I was going to redo this big personal project that I've been working on for years, and I knew I wanted to do it in a functional language, and I didn't know which one. And so I actually spent a lot of time investigating all the different functional alternatives out there. And Elm, PureScript, ClojureScript, Scala.js wasn't out yet, so I can't really speak to that one, but those three definitely all produce JavaScript code that's fast and has, it's high performance and good performance characteristics. And the other ones that I looked at, GAC.js, Fay, Haste, stuff like that, just it was not true. They were just produced very bloated, slow JavaScript. As far as Elm versus PureScript and ClojureScript, I would say that each of those had different trade-offs. So ClojureScript, of course, is a Lisp, which is either a great thing or a horrible thing for most people, depending on your perspective. Not a lot of in between on that one, and it's not type checked, so it's kind of a different comparison. Comparing PureScript and Elm, the two main differences are that PureScript is a lot more about sort of the quick and dirty FFI. So PureScript does not have persistent data structures under the hood; it just uses plain vanilla JavaScript arrays, which means that you don't get the performance benefits of having persistent data structures as it scales, but you do get easier JavaScript interop. So PureScript can just share code directly with JavaScript, which means that it's a little bit less safe. You can break invariants in JavaScript and end up with errors sneaking into your PureScript code in a way that you can't with Elm's port system. But it does mean that the interop is faster to write. So kind of like it's again that trade-off of like reliability versus speed. The other thing about PureScript is that it's got a lot more of a mathematical bent than Elm does. Elm is a very pragmatic language. It's sort of very blue-collar functional programming. Like we just want stuff to work and we want it to be reliable, and that's what we care about. Whereas PureScript is a lot more about we care about like all this whole like world of mathematical abstractions, and bringing that to the language is very much a core value of that community. And if you go to the two different communities, you'll find a lot more people who are interested in category theory and pure scripts, and a lot more people who are just interested in shipping stuff in Elm. So it's again that trade-off, like pragmatism versus a focus on more and more abstraction. And I think it's pretty exciting to be in a world where you actually have multiple viable functional languages that compile to JavaScript and work well in the browser, because a couple of years ago we didn't have any. And now we have, all these different alternatives, and depending on what your personal values are, what types of different things you're interested in, you have the ability to choose the language that's going to be best for you. That's amazing to me. I'm so glad that we live in this world now.
And if anybody's interested, oh, sorry, go ahead.
It has a lot more features, but it kind of feels sometimes it's too many features. Elm's a really refined language. It's pretty simple in the way the types work, but what that means is that it's really lowered the entry barrier for new developers to pick it up.
Yeah, I don't think I could have said the same thing of like Tessa being able to get productive in Elm with only months of JavaScript knowledge and no FP background, no category theory background, no static type system background, and just in her first week be writing production Elm code. That's one of the benefits you get from a simpler language.
Yeah, I don't think you'll find many people writing pure script that haven't written Haskell before. That's that's how I see it.
I would say that's probably true. No, thanks for having us. It's been fun.